and last name. Today's conference is being recorded. If there are any objections, you may disconnect at this time. Now I'd like to turn the conference over to the Jet Propulsion Laboratory. Thank you. You may begin.
Thank you very much. I'm Jane Platt in the JPL Media Relations Office in Pasadena, California. Today's topic is the dust storm that's currently raging on Mars, and we'll be talking about how it's affecting the long-lived Opportunity rover and how it's also providing interesting possibilities for various missions to study the science of the storm. We're going to be hearing from 3 speakers today, and we'll take questions from reporters on the line, and we'll try to take some from people who are asking questions on social media as well. You can follow along with the visuals at https://www.nasa.gov/Mars Dust Storm Telecon. Once more, that's https://www.nasa.gov/Mars Dust Storm Telecon. And again, as was mentioned by Dory, our operator, if you do want to ask a question later on as we get to that point, press *1 and we'll put you in the queue. I'd like to introduce our panel. We have with us here at JPL this morning John Callas, the Opportunity Project Manager at JPL. We also have Rich Zurich, the Mars Program Office Chief Scientist at JPL. And at NASA headquarters, we have Jim Watson, the Director of the Mars Exploration Program at NASA. And we do have one other person who will be with us and available to answer questions, and that's Dave Lavery, the Program Executive at NASA headquarters for the Opportunity and Curiosity rovers. We're going to start now with John Callas. John?
Thank you, Jane. There's a severe dust storm on Mars that's threatening Opportunity. As a result, the rover has fallen asleep and is waiting out the storm. The project team is very concerned. We're watching the weather, and we're listening with the Deep Space Network for signals. But let me give you a timeline of what brought us up to this point today. Back on May 30th, MRO, the Mars Reconnaissance Orbiter, saw the first indications of a dust storm on Mars. They notified the MER project on Friday evening that the dust storm was headed in a direction that may affect the Opportunity rover. At that time, we already had a 3-day plan on the rover that was running over the weekend. Over the weekend, we did see increases in atmospheric opacity, which is a measure of the amount of dust in the atmosphere. There's a graphic online that you can refer to. It's labeled Callas 1. And it shows the subsequent atmospheric opacity measurements, starting with what we call a tau of 1, 3, 5, 7, 9, and 11, all the way on the right-hand side. So we can use that for reference as I refer to these numbers. So on the weekend, on June 2nd, we observed an atmospheric opacity of 0.6, which is about normal for this time of year. The rover was generating 645 watt-hours. The next day, the atmospheric opacity jumped to 1.5, so that's a pretty significant increase in one day, not uncommon for the onset of a storm. We continued to watch things as over the weekend, and then on Monday morning, we began our next planning day for the rover, and we, at that point, decided that we needed to cease science operations and to configure the rover for a lower power operation as this dust storm was increasing and looked to be more threatening. So on Monday, we measured the atmospheric capacity at a little over 2, and at that point, the energy production of the rover had dropped by almost half to 345 watt-hours. We continued on the next day with another low-power plan, and we were unable to get a measurement of atmospheric capacity on the next day because it had likely increased to such a high level that our ability to measure it is diminished. But we did measure the energy production of the rover, and it had dropped to about 133 watt-hours. So again, by more than a factor of 2 in one day. So our concern level continued to increase. So on the next planning day, which was Wednesday, June 6th, we decided that we were going to do a 2-day plan, and we chose not to have the rover communicate to us on the first day, but wait until the second day. and this is a power-saving measure. So essentially, the rover just wakes up in the morning, receives the commands, goes back to sleep, sleeps through the night into the next day, a brief wake-up in the morning, going back to sleep, and then wakes up in the afternoon, tries a measurement of atmospheric opacity, communicates with one of our orbiting relay satellites, and then goes back to sleep. So very short duration of uptime. However, we do want to maintain some level of activity on the rover because that's what keeps the rover warm. So we're trying to not only manage power consumption, but manage the temperatures on the rover. So on Friday, we planned a 3-sol plan to carry us through the weekend. Again, we were implementing a very low-power plan where we essentially shut everything down except one wake-up for measurement of atmospheric capacity and a coincident communication with a relay orbiter. In that case, it was the Mars Reconnaissance Orbiter. So we did get that data down on the ground. That was on Sunday, June 10th. The rover was still active at that point, but the atmospheric opacity was estimated at 10.8, and that is a record high for measurements on Mars. And that would correspond to the graphic, the right-hand panel. So it's completely black on Mars. It's completely dark. The energy production of the rover was measured at only 22 watt-hours. Even though we heard from the rover was under master sequence control, I made the decision to declare a spacecraft emergency because there wasn't enough energy for the rover to sustain activities, and it would be dropping into what we refer to as a low-power fault. This is where the rover senses it doesn't have enough energy to maintain activities, and it essentially turns everything off with only the master clock connected to the batteries. So all energy that's coming out of the solar rays is going into the batteries and the master clock. That was the last communication we had from the rover. We did listen for a fault window on the rover. We also sent commands to elicit a response from the rover, and we've heard nothing since then. So our expectation at this point is that the rover has gone to sleep. It's in this low-power mode, and that will remain in that low-power mode until there's sufficient energy to charge the batteries back above a certain threshold. At that point, the rover will autonomously try to wake up and communicate with us. So at this point, we're in a waiting mode. We're listening every day for possible signals from the rover and be prepared to respond to that. Going forward, though, the concern is temperature on the rover. Because the rover is not active, it will be getting colder. The good news there is that the dust storm has warm temperatures on Mars. We're also going into the summer season, and so the rover will not get as cold as it would normally. We've done an estimate that shows that the rover should stay above its minimum allowable operating temperatures for the long term. So we should be able to ride out the storm. When the sky's clear and the rover begins to power up, it should begin to communicate with us. There's one last complexity that we'll have to deal with, and that if the rover is generating less than 22 watt-hours of energy, that we won't have enough energy even to sustain the mission clock, and we'll have what's also called a clock fault, which means the rover doesn't know what time it is. And so at that point, the rover goes into an autonomous mode that when it does have power to wake up, it sets timers at regular intervals just to wake up to see if it can communicate to Earth. It waits until there's sufficient energy on the solar rays, so it's going to use the solar rays to know when it's daytime, and we will be prepared to listen and respond to the rover when that happens. So we're concerned, but we're hopeful that things the storm will clear and the rover will begin to communicate to us. We're supported by a great team. We're very appreciative of all the assets at Mars that are looking out for us and providing communication services. The entire Mars program and the Deep Space Network is providing us with excellent support. So at this point, I'll turn it over to Rich Zurek.
Thank you, John. The situation on Mars really highlights a key question about Mars today, which is why do these massive, widespread dust events occur in some years but not in other years? Local dust storms, similar to those that occur in the American Southwest or the Middle East, for instance, can occur in any season on Mars, but they typically grow to continental size only during the southern spring and summer when Mars is a little closer to the sun. Of those regional storms that do occur, only a dozen so have ever, in the historical record or the modern record, expanded to encircle the planet or cover the globe. Thanks to the ongoing Mars exploration program, Mars has been monitored by a series of spacecraft orbiting the planet on essentially a daily basis for nearly 20 years. Planet-encircling storms were observed in 2001 and 2007. However, in the 5 Mars years since then, no regional storm had grown to planetary scale, but the current storm on Mars is just days away from meeting that classification of a planet-encircling dust event. Each observation of these large storms brings us closer to being able to model these events and perhaps even one day to forecast them. This would be like forecasting El Nino events on Earth or the severity of upcoming hurricane seasons. There are ideas about how to do this, but we need data to test and refine them. The first set of images, Zurich 1, shows you the evolution of the storm from an initial dust cloud. The storm here is colored in red for visibility so that you can see its expansion as it goes across the planet. On May 30th, there was just a small local storm that had appeared and was spotted by the Mars Reconnaissance Orbiter's Mars Color Imager team. And they put together these global maps, which are formed by a mosaic of 13 color strips that show the entire globe, but each portion of the planet is viewed as if it were at 3 p.m., because that's when the orbiter overflies that area of the planet. The black areas are poorly lit polar regions at the top and bottom of the diagrams, and there are a number of data gores that are due to spacecraft loads for high-resolution imaging of the surface or to data loss during transmission to Earth. As you can see, the time series shows that the storm headed south towards opportunity, and that happened on June 1st. And that was the moment when it was realized that there was an event that could potentially affect the rover closer to the equator. You also see that there's bands of bright cloud that go off and stretch across the planet, and the entire dust haze is now spread over about a quarter of Mars. And remember that Mars has got the same area as the land area of the Earth, so this is a very widespread event. These active areas and associated dust are collectively called the dust event, and the original storm eventually merged with local storms that originated in the southern hemisphere, and that haze is now spread over Gale Crater, where the nuclear-powered Curiosity rover has measured increased opacity and seen greater haziness within the 6-kilometer deep crater itself, as seen in the next chart, Zurich 2. And there you can see the change in visibility of the rover as it looks out across the floor of Gale Crater. As the dust storm expands, the dusty atmosphere absorbs sunlight, producing a powerful feedback. Because the heating changes temperatures and pressures, those drive winds and thereby expand the regions where dust can be raised. When dust gets higher in the atmosphere, this feedback can change the global circulation. And the MRO Mars Climate Sounder has seen it go several tens of miles into the atmosphere. Although the dust reached those altitudes more slowly in this storm than is typically the case. In the final chart, Zurich 3, you can also see the integrated observations by the NASA spacecraft, MRO, MAVEN, Mars Odyssey, Curiosity, and Opportunity rovers that are working to characterize this rare event. Knowing why dust storms grow so large in some years, but not in other years, is important to understanding the climate of Mars, past and present, and also to supporting future missions. To tell more about the program, let me turn it over to Jim Watson, Director of NASA's Mars Exploration Program.
Thank you, Rich. The current dust storm is providing us with an unprecedented opportunity to learn more about Mars and the many challenges that it presents for exploration. We are fortunate that we have a record number of operational spacecraft at Mars, enabling us to observe the storm from many different perspectives. We also have another spacecraft on the way to Mars, the InSight lander, and it will be useful for us to be as prepared as we can for its arrival at Mars in the end of November this year. Knowing and understanding how these storms behave will be critically important for our more ambitious missions that are being planned for the future, such as Mars Sample Return, which is envisioned to be solar-powered. As we work to pave the way for when human explorers arrive, it will be essential that we learn to monitor and hopefully predict these storms in order to help ensure the safety of the crew. Turning to the present, we're all pulling for opportunity. As you know, it's been a remarkably resilient rover, lasting 15 years, well beyond its original design life of just 90 days. Its longevity has taught us much about operating on the surface of Mars. But regardless of how this turns out, this little rover has proven to be an invaluable investment that has greatly increased our ability to explore the red planet. Thank you.
All right, thank you to all our panelists, and we're going to start with the Q&A portion of this media telecon. Again, if you would like to ask a question, please press *1 and give the operator your name and your affiliation. We're going to start first with Mike Wall from space.com. Mike, good morning.
Good morning. Thank you guys for actually doing this. Just like a couple of quick questions. I mean, how many days do you reckon Opportunity has before you really will get really concerned about like whether it's going to be able to kind of pull out of this? And how like low can the temperatures go before things get really kind of dicey? And kind of how does that compare to what Spirit went through in 2010?
Okay, well, first, let me address the second part first. The big difference between now and what Spirit went through back in March in 2010 is Spirit was going through winter. So the temperatures were a lot colder and there was a lot less sunlight. Here, we're approaching summer, and as soon as the sky's clear, we'll have ample energy production. The question is, how long can the rover go? Right now, our thermal predictions is we have a detailed thermal model of the rover set in the environment, and we use the last recorded information from Mars, and we've run that model out for many days. And what we find is that the rover hits a steady state temperature where there's a balance between what little energy is coming out of the rover and being lost in the environment. I should remind you that the rover has on board 8 plutonium RHUs. These each generate about 1 watt. So even though we're not getting any solar energy on the rover, there is still about 8 watts of thermal energy inside the insulated box of the rover. And so in a couple of days, we should hit that steady state point, and we should be able to sit there for an extended period of time until either the sky is clear and we get power, or if the storm persists, it's expected that these temperatures would persist around the vehicle. And then, how cold can the rover go? Well, it was designed to go to minus 55 degrees C. Its flight allowable temperature is minus 40 degrees C. And so the coldest temperature we predict to see is minus 36 degrees C. So we think we can ride this out for a while.
All right, thanks, John. And two things. First of all, we do have quite a few reporters who are waiting to ask questions. So on this first round, we're going to limit it to one question, and if needed, one quick follow-up, and time allowing, we'll go back. Also, to our panelists, to our speakers, if you could identify yourself, since people can't see you, and you might accidentally get attributed with somebody else's quote. So anyway, we're going to take our next question from Marcia Dunn of Associated Press. Marcia?
Yes, thank you. What's the chances of Opportunity being buried under dust, like under a big dune, and buried alive, so to speak? And is there any risk to Curiosity?
This is John Callas. I'll take that, and maybe Rich might follow up. The physical volume of dust that would fall on the rover is really tiny. We're talking about a monolayer, literally a single layer of dust that could accumulate on the rover. So so there's not a concern of the rover being buried. There is a concern that once the sky is clear, we may have a lot of dust on this vehicle that we'll have to deal with. Rich, did you want to?
So Curiosity, being nuclear powered, and the fact that the dust haze has not been as thick there as over Opportunity, is actually trying to do some science by looking to see if there's dust movement inside the crater itself. And they're not too worried at this point. And I'll just repeat what John said, which is that we're talking, if you took all the dust out of the atmosphere here, it's a very thin cover. And, in fact, in many respects, it's kind of like what falls out on your car on a summer day sometimes. But in the atmosphere, it's very absorbent, and that's what's producing the darkness of the surface and scattering the solar radiation out.
Okay, thank you. We're going to take our next question from Bill Harwood, CBS News.
Yeah, hi. This is for John Callas. I might have just misunderstood you. I wanted to make sure I understood what power level you thought you were at when you last heard from it. In other words, is the clock still running, or do you think you're in that mode you were talking about? I was confused between 22 watt-hours and 24. Thanks.
Right, yeah. So our last measurement of energy, which was from the last time we heard from the rover, was approximately around 22 watt-hours. There's a fair amount of uncertainty of it because, these numbers are so low. And that's roughly the amount of energy you need to maintain the mission clock. So if we've hit a minimum in energy production, then we should be able to maintain the clock. However, if the storm gets worse, if the atmospheric capacity is increasing, that energy level will drop, and we won't be able to sustain the clock. And at some point, we'll have a mission clock fault, which will be a more complicated recovery.
Thanks.
All right, the next question comes from Dan Vergano at BuzzFeed. Dan?
Hi, thanks very much. Could you talk a little bit about that more complicated recovery? If that's what happens, how many days of watching and waiting are we talking about, and sort of how will that play out?
Okay, so this is John again. We likely are in a low power fault right now, which means that the rover just shuts everything off and it waits for power to come back. And when power comes back, it knows to communicate during a very specific time in the middle of the day, essentially noontime. And so we know when to listen for the rover. So if we come back when the sky's clear, we would expect to hear the rover in one of these fault windows. If there's a mission clock fault, it means the rover doesn't know what time it is. And so the rover then starts to set a series of check or alarm clocks at regular intervals to wake up, actually not really to wake up, but actually to see if the sun is up. If the sun is up, then it attempts to wake up. If it's not, then it sets another one of these alarm clocks to check roughly 4 hours later. So it tries to look for the sunny time of day and then to wake up. And so the timing of that is uncertain because we don't know when that 4-hour alarm clock will expire within the solar illuminated time of the day of the rover. So it means we have to watch and be vigilant, and that's the complexity there, just uncertainty on the time.
Thanks very much.
All right, the next question is from Joe Palca from NPR.
Hi, thanks. 2 questions, I guess. One, how did Opportunity do in the 2000 dust storm? And the second is your modeling of how long things are going to work complicated by the fact that the battery is now 14 years old on Mars and may be behaving differently?
Let's see. So the 2007 dust storm, Opportunity, fared well through that. We were able to maintain sequence control the entire time through that dust storm, but we did have periods of time where we didn't hear from the rover for 4 days, where we chose to have it minimize activities and then communicate with us on the 4th day. So we were able to ride that out, but we were always under sequence control. Here, as of today, our expectation is that we've already gone into low power fault. These are just historic low energy levels for the vehicle. I'm sorry, remind me your second question, second part of your...
Battery behavior for prediction?
Yeah, even though these batteries are 15 years old and they have over 5,000 charge-discharge cycles, they still have about 85% of their capacity. They are really the finest batteries in the solar system. I mean, I only wish my cell phone battery had half of that. So we actually have fairly robust batteries at this time. I mean, there is uncertainty. There's likely higher internal resistance, but we think the batteries will ride this out well.
This is Rich Zerka. I want to point out that there's tremendous variability in the opacity across the planet, whereas Opportunity is seeing numbers of this tau as a measure of that opacity at 14. Curiosity is seeing more like 2 to 3 at the moment, although that number's rising. We hope that maybe it'll open up and clear skies over the rover. One of the unusual things about this storm was the fact that it started as a local storm, which grew, Normally, those local storms kind of sweep on by Opportunity Site and go down into the southern hemisphere before spreading out into a much bigger event. That didn't happen this time. The storm sort of stalled over the site and has produced this record measurement of an opacity of above 10.
Okay, the next question we're going to take is from the Washington Post and Sarah Kaplan.
Hi. I'm wondering if you guys can talk a little bit more about what we know about what causes these storms and how, and also how long this one is expected to last.
This is Rich Zurich. The storms are starting out as a local storm, and that's pretty much similar to our experience here on Earth, where you have strong winds, maybe associated with a storm system, a front moving through an area, and you have movable dust on the surface, and that's all you need for a dust storm. Once it begins to grow, however, the dust can get lifted higher into the atmosphere because the dust sort of lofts itself because it absorbs the sunlight coming in, heats up, and that changes the circulation to raise it higher into the atmosphere. It's that how high in the atmosphere does it go? Because once the storm is not raising dust anymore, the dust begins to fall out. But the higher elevation it is, the longer it will take to do that. So there's sort of a correlation between how opaque and how high the dust goes and how long the storm will last. Typically, you get back to background levels in a few weeks. For the very largest storms, that could be a few months.
And the reason we don't get storms like this on Earth is just there's not as much dust, or?
The Mars atmosphere is pretty thin, and so when you get something that can absorb radiation in the atmosphere and heat it up, it responds very quickly. On the Earth, there's a lot of heat reservoir, oceans, water in the ground itself, and that tends to kind of modulate the response to it. It's not as immediate or as large. Mars is sort of extreme in that regard.
Thanks.
I'm going to take a question now from Tom Risen from Aerospace America.
Thank you for doing the call. This is Tom. I'm wondering if this, I know you thought that dust was going to be a problem for solar power when you got into this, but did this catch your engineers by surprise? Does this add any urgency to produce more plutonium for spacecraft power?
I think that's probably a question for headquarters.
Yes, this is Jim. I think when we started out with our systems on a solar-powered design, we were fully aware that this possibility exists. As Rich explained, storms occur, but they do not occur with a regularity that we can count on or a coverage that we can count on. So that in the balance of finding an engineering solution that works and that's affordable, we settled on solar power for the initial machines. The larger rovers, we're not able to support the kind of ambitious operations that we're doing with them using solar power. The arrays are just prohibitive in size, and so that's fundamentally why we switched over to the nuclear power.
All right, thanks. We're going to take a question now from Nature magazine and Alexander Whitsey.
Hi, thanks for taking my call. My question is about InSight on its way. Is there any chance this storm, if it goes global, could last until its landing? And if so, how would that affect EDL for InSight?
This is Jim. I'll take that. The InSight itself uses inertial measurement unit, if you will, or a gyroscope to provide its primary guidance, and then on touchdown it uses radar for the final phase of the landing. Neither one of those are bothered by the dust. So if we were to happen to end up in a situation that there was a dust storm at the time of landing, we could fly right through it. I think Rich can comment in terms of the longevity of the storm. I don't think we would expect this storm to last much longer than a month or two. But it is unprecedented in the pace at which it has grown and spread across the globe. But end of November 26th, if I recall right, is when the InSight landing is.
So this storm is not expected to last. The question is will a second storm develop later in the year? Because we have seen that in previous Mars years. It is a rare event, but we did see that during both the Mariner 9 spacecraft encounter and the Viking mission back in the 70s. InSight has prepared for looking at what that does to the environment and how that might affect things like EDL as it descends to the surface and such. And they have considered all those situations of a global dust storm, a regional dust storm, and they think they have margin to adequately deal with all those.
We're going to hop over to London now. Jonathan Amos with the BBC.
Thank you, Jane, for the opportunity. Can you just give us a quick update on the health of RPIs? I presume we're still driving backwards and we've got a few arthritic joints still.
Yeah, this is John Callas. Prior to the storm, the vehicle was in actually remarkably good health. You were recalling that we, at a time, had to drive the rover backwards because we were concerned about wear on one of the steering drive actuators. That's actually been well behaved. We've been doing that for now almost a decade. There is one arthritic joint on the robotic arm, but we've been able to compensate for that. We did have a challenge with one of the steering mechanisms, so we've actually stopped using that steering mechanism. So we're now a two-wheel steering vehicle instead of a four-wheel steering vehicle, so we drive more like a car. But other than that, the vehicles, it was in remarkably good health. The cameras were in excellent shape. The alpha particle spectrometer was collecting excellent data. So we're eager for this storm to clear, recover the rover, and continue on with our exploration.
So you've still got all your instruments?
Yes. I mean, dust will be a concern. We'll likely have some dust on the optics, but our experience from the last dust storm is that the dust actually sheds off the optics over a short period of time, and we can calibrate out any remaining specks on the glass.
Any further question now from Irene Kloss at Aviation Week.
Hi, thanks very much. Can you give us a little update on the science that Opportunity was doing prior to the dust storm?
Yes, this is John Callas. I'll start that, and maybe Rich might add into it. We're at this feature called Perseverance Valley, which is a channel that's carved in the rim of Endeavour Crater. From orbit, it looked like it might be fluvial carved. I mean, some fluid may have carved this feature. And so we're in the process of exploring that. We're about halfway down, and we're testing several hypotheses to its origin, whether it was flowing water that might have carved this, or whether it might have been wind erosion or a combination of factors. So that's our primary science objective right now. Once we're done with that, we intend to move further down into the crater along the inside rim and look at the different layers of the crater to assess the different geological epochs that are revealed on the inner edge. Rich, I don't know if you wanted to add anything more to that.
Well, I think the exploration that Opportunity was doing here shows the example of, it's pretty easy when you look at something from orbit to say, I think I know what that is. And then you get down on the ground, and you begin to see it's a lot more complex. And the testing of the hypothesis would still be going on once Opportunity recovers from this storm. Getting down to the floor of the crater, seeing some of the debris that was there would really help us understand whether these are wind-carved or fluid-carved or exactly what we're looking at. It just shows that ground truth is a good thing.
Okay, we still have quite a few people from the reporter lines waiting to ask questions, and we have some people on social media as well. For right now, we'll take one more from a reporter, and then we'll have to a couple from social, and then we'll come back to the reporters. So the next one is from Alan Boyle at GeekWire.
Oh, hi. Thank you for taking the question. I wanted to hear a little bit more about the effect on the team itself. I've seen some tweets where people are really concerned. Have you had to reassure members of the team that it's all going to be all right, or what's the mood of the team?
Yeah, it is concerning. I mean, this team has a very strong bond with the rover. We have a very tight emotional connection with it. And we're concerned about it. I mean, obviously, we anthropomorphize this rover. And, the analogy I would use right now, it's like you have a loved one in a coma in the hospital. The doctors are telling you that, okay, you just got to give it time and she'll wake up. All the vital signs are good, so it's just waiting it out. But, if it's your 97-year-old grandmother, you're going to be very concerned. And so we are. And by no means are we out of the woods here. This storm is threatening. We don't know how long it will last, and we don't know what the environment will be like once it clears. We are all concerned, and you can see it in the team members.
Thank you. The first question we're going to take from social media is from Twitter. Kevin asks, are there any concerns that dust will accumulate around the wheels, possibly preventing mobility?
No. Again, the amount of dust in the storm will correspond to just a single layer of dust on the rover and the terrain around it. So we're not concerned about mobility limitations. I think our biggest concern is, how much power will the rover produce, and whether the dust has, put a lot of particles on the optics of the cameras. But we're not concerned about mobility at this point.
This is Rich Zurich. The Opportunity rover is on the rim of Endeavour Crater, Perseverance Valley is. That's kind of a windy area. As long as dust isn't being raised locally or transported in, the wind will actually help clean off the arrays. And Opportunity has seen several of those events in the past.
Okay, the next question from social media is from David on Facebook, and he's asking if you have an idea how long the dust particles will be suspended in the atmosphere.
Well, this is Rich Zurich again. That's a good question. And it's typically how high are they going to go? How high will they get lofted in this big event that's actually changing the global circulation and taking things maybe far outside the active dust-raising area? In a global storm, that is the biggest, largest storms that we've seen, the dust can be taken up above 70 kilometers, and it takes 2 or 3 months to fall out from those altitudes. So just kind of think of it, it's kind of like when an ash cloud goes over, there's a settling out of the materials and stuff, and that, of course, depends upon the winds, whether it's raised again locally or such. But normally in these storms, there's a long decay phase of clearing out of the atmosphere, again, taking several weeks to a few months.
Are you going to come back?
I think I just want to, state again, having this dust storm occur under the visibility of the whole fleet of orbiters that we have, and eventually here at Curiosity participating in the research as well, is going to teach us a whole lot about how these storms behave and what the consistency of these are. This is not like a desert storm that shifts major sand dunes here on Earth, but this is more like talcum powder that's lofted into the atmosphere and eventually gets distributed across the globe. But exactly how all that behaves, as Rich alluded to, we understand some of the principles, but we need a lot more in the way of observations, and this storm is going to provide us with more answers to a lot of the questions that you're asking here. Right now, we're kind of giving you generalities, but that's where our state of knowledge is right now.
Thanks. We'll try to get back to some more social media questions. For right now, we're going to go to Leo Enright at Irish Television. Hi, Leo.
Thanks very much, Jane, for doing this. I'm just wondering about collateral damage to other missions. For instance, MAVEN, were there plans or are there plans for a deep dip into the upper atmosphere at this particular time? Is that something that would be a concern? I know it's somewhat higher, but not all that much higher than what you're talking about for the dust height. And I also do wonder a little bit about Curiosity. Is there anything on that rover that is potentially at risk from a heavy dust fall? Are there any precautions that you need to take there?
We'll take that at headquarters. Dave?
This is Dave Lavery. With regard to the orbiters, we don't anticipate any hazardous effects from the dust storm. They're at a high enough altitude that they'll be able to orbit safely above it and yet conduct observations all the way through the process and give us a lot of observational data that will inform us quite a bit more about how these storms actually operate and function. But we don't expect any hazards there. As for Curiosity, we have noticed already a darkening of the skies above the Curiosity landing site all the way on the other side of the planet from Opportunity's locations. But because Curiosity is a nuclear-powered rover, we're not having the same concerns with regard to the power generation, so there's no issue there. The only thing that realistically could possibly be a concern would be if the storm goes on long enough and if there were high enough wind velocities, would there be any issue associated with dust being deposited on the optics? We've already taken a look at that based on past experience with these storms. We don't expect anything to happen there. So the short version of that answer is Curiosity should be fine.
Okay, and I want to thank all the reporters and the people on social media for being patient. We do have a lot of questions today, and we're going to try to get as many as we possibly can in before our time is up. So the next one will come from Ken Kramer at Space Up Close.
Hi, thank you for doing this and taking my question. For Richard Zurich, I guess it sounds like you're saying that the dust storm is still going to get worse. So can you make some projection, even a guess, how long that might be? And then for John Callas, are we talking about the rover being able to survive then for weeks and months on end at this low power mode? Thanks.
Okay, this is Rich Zurich. In some sense, the storm is not going to get a whole lot worse at a given site like Opportunity. What is changing is the storm is producing a dust haze that is spreading over the planet and getting raised higher into the atmosphere. That can lengthen, as we've been talking about, how long it takes for the storm to clear. We're not expecting the opacities over Opportunity to get a lot worse, but it doesn't really matter because there's almost no sunlight reaching the ground now anyway, except a little bit scattered in a very dusty sky. So that's not going to change very much. How long this storm will last, that we're not certain about. That is one of the issues that we're trying to understand about it. As Jim Watson said, this is one of the things we want to learn is what initiates that so-called decay phase where the dust areas stop being active, raising dust into the atmosphere, and everything just begins to fall out. Now, part of that can be the storm itself. As I spread dust all around in the atmosphere, it sort of smooths out some of the pressure gradients that drive the winds and such, and the winds will eventually die down. And exactly when that's going to happen, whether it's next week or 2 weeks from now, we don't know. John?
Yeah, thanks, Rich. So this is John Callas. The question about how long the rover can go in this situation. As long as the rover stays warm enough, and our predictions are that it will, that we can go, any number of days. We are approaching summer, so we haven't even hit the warmest part of the year for the rover at this site. And in terms of this low power mode that we're in, the rover actually goes into that every single day. We have a process which we call deep sleep, in which once we're done with activities on the day, we disconnect the batteries from the rover and only the mission clock is connected. And so we've been deep sleeping now for thousands of sols. And so this is just like deep sleeping, except we're doing it throughout the entire day, not just at night.
Next, we're going to Space News and Jeff Faust.
Hi, thanks for doing the call. I've heard a lot of discussion about this storm being unprecedented. I wonder if there's any way to quantify the intensity of the storm and compare it to some past global dust storms that have been observed on Mars. Thanks.
Well, there are a couple of metrics that we use. One of them is just how much of the planet does it cover. If you will, the most global of those storms occurred back in 1971 when Mariner 9 was approaching Mars to go into orbit, be the first spacecraft to go into orbit around another planet. And the entire surface, except for a little bit up around the poles, was obscured. In fact, they noted that they were seeing things that they called north spot, middle spot, south spot, and those were the summits of the Tharsis volcanoes, which stand some 20 kilometers above the surrounding plains. So that was a very massive storm. This has not reached that. It has not spread over that large an area. However, there are some areas, as we've seen over Opportunity, that are incredibly dense, and that's interesting in itself. The other aspects of this storm is that it didn't seem to raise dust into the upper atmosphere, higher into the atmosphere, it was more slow than that has happened in previous storms. Another aspect is that although these storms tend to go big during southern spring and summer, it's just barely into southern spring. And this is the earliest except for the 2001 storm. However, this storm pretty much spread in the northern tropics, whereas that storm went into the southern hemisphere, and that's where it encircled the planet eventually. So it's those kinds of features. It's extent, it's the opacity of the most active areas of dust raising, and it's how high material gets lofted around the planet. And of course, what we'd really like to understand is what are the triggers that say this is going to happen at this time in the season, or even in this year as opposed to some other year.
Rich, this is John Callas. Let me just add, from the rover's perspective, the 2007 storm, it actually took several weeks for the atmospheric opacity to build up to somewhere around 5.5. This storm for us, where we're located on Mars, took just a few days to go to opacity of greater than 10. So this one had an onset for opportunity that was an order of magnitude faster and more intense than the 2007 storm.
Yeah, the 2007 storm for opportunity is more like what Curiosity is seeing, where it's taken several days for the opacity to start to build up above the side. And again, part of that is because this time around, the local storm that served as the original core of the event kind of parked right over the opportunity side.
Our next question is from Science News, Lisa Grossman. Lisa?
Hi, thanks for taking my question. I was wondering if you could tell us a little bit more about the specific data you'll be collecting to study how the storm works.
This is Rich Zurich again. So we had the graphic Zurich 3 that showed the fleet of spacecraft. So what we're doing is, well, what Opportunity has already done, which is take a look at the opacity of these of the atmosphere itself. We've also got looking at the spread of the storm with our weather cameras and such, and we're looking at that both in the visible images that you've seen here, but also in the infrared, because that tells us something about the particle size and the composition of the material that's in the dust. We're also looking at how the atmosphere is affected by looking at the temperatures and such. We don't have many direct wind measurements. We do very high in the atmosphere. And another aspect of what we look at is how does it affect the upper atmosphere, where Maven is dipping down to about 160 kilometers, about 100 miles up. They're safe. They're able to do that. But it's very interesting to see the response of the upper atmosphere to the lower atmosphere, and we can fold that into future missions that may aerobrake or aero capture in the future.
And our next question is from Jackie Goddard, The Times of London.
Hello, thank you. What would be the possible implications of a storm like this for a potential human settlement on Mars? What are some of those questions or answers that you can take away from this to possibly need to adapt potential future manned missions?
This is Jim Watson at headquarters. I think the big takeaway here is that we really need to understand these storms to the degree that we can have some level of forecasting capability. So clearly, operations outside the shelter for human exploration would clearly have some constraints on them. We would not want to have a crew, if you will, operating remotely from their base and be caught off guard with a storm like this and have difficulty getting back home and things like that you can imagine. So I think the primary thing, the takeaway from this is, in order to support humans safely, just as you do with difficult operations here on Earth, is you need to be able to have an understanding of the circumstances in which they're going to work. And being able to forecast the weather and environmental conditions is just one of the most fundamental things that we'd want to be able to support the crews with.
Thank you.
Thank you. And we're going to take a question from Emily Lakdawala with the Planetary Report, and then we'll get a couple from social media. Emily, go ahead.
Hi, thank you.
I'm wondering, I know that Jim Shirley predicted a global dust storm for last year and then for this year. I'm wondering how much advanced planning went into the coordinated observations that you're doing, and if it changed any of the way you were operating Opportunity even before the dust storm started.
Well, let me take the question about Opportunity then. I think there's a further question for Rich later. We didn't have to make any changes. We had very good dust factor, which is the amount of dust on the solar array, so our energy production was excellent going into this period of time. We already had taken steps to maximize energy production anyways, just so we can do as much science as possible. So there were no real measures to take, and in hindsight, there wasn't really anything we could do to set us up any better than we are going into the storm. Rich?
And we've sort of been expecting to have one of these storms. If you looked at the historical record, telescopic observations and early spacecraft observations, you would expect maybe a period of no storms of about 3 to 4 years based on that record. Well, we're 5 Mars years away from that. And so we've been trying to be prepared for this storm. We've defined observation sequences that we would implement if the dust got high in the atmosphere, for instance. And a lot of it is just to continue the standard monitoring of the planet, because that's what enables us to catch those early stages, which we're really interested in. Yes, there have been a number of hypotheses put forward for why dust storms occur in some years and not others. The problem is we're dealing with a small number of events, and it's difficult to correlate that. Well, we have one more event in that family now, and that may help us illuminate and test some of these hypotheses.
Okay, we're going to go to social, and then we'll hop back for the remaining reporter questions. We've got one from Twitter. Chris is asking, has it been considered for future missions to have a method for the rover to clean the panels?
Well, this is John Callas. I'll address that. That's a question that we get a lot. And that was considered at the time that we were developing the MER rovers. But again, we were planning for a 90-day mission. Some of the challenges that you have with that is that suddenly you have another mechanism that's mission critical. Whether it's windshield wipers or vibrators or a tiltable solar array, and so you have to account for the possibilities. Well, what if those break? And so for us, the simplest solution was just make the solar arrays bigger, and that's what we did for MER. Future missions, I know, do this analysis as well and give consideration to what would be the right approach. But so far the design we have has worked really well for 14 and a half years.
Okay. And
this is Jim from headquarters. Let me just add to that. The rovers have been machines of discovery, landed on the surface and set free to explore as long as they can last, and we can support their operations. As we go into the future with more specific and targeted missions, one other consideration is when we operate the mission. As Rich mentioned, there is some degree of predictability. There is a dust storm season, and so one tool that the engineers have in planning the mission operations is to plan the critical operations at that time of the year where there are not a high likelihood of a storm to occur.
One more question from social. Namishka Mandanka on YouTube asks, are the particles in the Martian dust storm heavier than those on Earth? Rich, want to take that one?
Yes, interesting question. I would say no. The density of the particles are about the same and such, so if you weighed them on a scale, they would be much like dust on the Earth. There may be differences in particle size because not all dust is the same. It's generated in different sources on the planet. But by and large, you'd recognize it as dust.
Okay, and the next question comes from Jason Ryan, who's with Spaceflight Insider.
Hi, guys. Thanks for taking my question today. Real quick, I noticed that it states that the Opportunity's batteries have to look, if they dip below 24 volts, at that threshold, the rover is designed to turn off all subsystems except for the mission clock. Does this include the vehicle's electronics heater, though?
Yes, it. This is John Callas. Yes, it does. We actually turn off all the electronics every day on the rover, and we allow for the thermal inertia of the electronics to stay warm enough until the next morning when we power things back up. So right now, everything is turned off on the vehicle, and the temperature is determined solely by the environment and those 8 RHUs that are inside the rover.
Okay, the next question is from Tony Rice, WRAL-TV in Raleigh, North Carolina.
Thanks for taking my question. So the word dust storm creates a certain visual, and I imagine many are probably envisioning what was portrayed in the first couple of scenes of The Martian. Could somebody describe the current environment opportunities in, particularly the winds that are being experienced?
To raise dust off the Mars surface, you need wind speeds, we think, of about 30 meters per second. That's around 70 miles per hour and such. This atmosphere is very thin, though. It's only about 1% of the Earth's atmosphere. You're not going to blow spacecraft over with it, even though you're able to raise dust off the surface. And the way we think that happens, actually, is you take somewhat larger particles that sort of sandblast across and dislodge the finer particles into the environment. It looks like you look at the images of the storm and such, and you can see a sort of modeling what we'd call convective activity and such. So it looks like that there is still dust being raised in the vicinity, although it might not be exactly at the rover site itself. And some of that's falling out. Some of it is getting suspended again. The temperatures, when you have such a thick dust haze, the nighttime temperatures are actually warmer, and that's helping out opportunity. And it's sort of a greenhouse effect in which the radiation that otherwise would be lost to space is trapped by this haze and radiated back to the surface. During the day, the air temperatures near the surface are lower because much of the sunlight has been absorbed by the dust cloud above your surface. So there's probably still some winds in the vicinity of opportunity. Many of the other areas, the surface winds may not be very strong, but the winds are typically stronger at altitude, and that's what's spreading the dust haze around the planet.
We're going to take one really quick question, and then we're going to wrap up. Hopefully, Sally Rail, Planetary Society, I hope you have a quick question.
I do, actually. Can you hear me?
Yes, we can hear you fine.
Okay, great. Thank you. Is the storm still parked or stalled over Endeavour? And I just wanted to confirm that the estimate is for it's about 2 days for the storm to become planet encircling. Thank you.
This is Rich Zurich. Yes, we're expecting, if you look at the images again, you notice that in the northern latitudes, it's just about wrapped around except for a small part of the planet above Tharsis. The southern area looks very active as well, and we expect that at the speeds the dust haze is expanding, that it will wrap around the planet in 2 or 3 days, something like that. Let's see, what was the other part of your question?
Is the storm still stalled or parked over Endeavour Crater?
Well, there's still an active dust-raising region over it. The storm is now expanded so that there are many other dust-raising areas across the planet. And together, those are contributing to this almost planet-encircling dust haze now.
All right, thanks, Sally. And thank you to all of our panelists and to all the reporters and to the folks on social media who asked some excellent questions. We do have a replay that will be available. It's generally up about an hour after the telecon ends. I'll give you a couple of phone numbers. That's 888-562-4913. The international line is 402-530-7670. And the passcode is 489541. I think we'll try to put those numbers up on the website that you're viewing today. And speaking of websites, if you do want more information, you can go to mars.nasa.gov. There's a lot of information there, including a new section that's visible on the front page called Mars Storm Watch. It's all about this dust storm and dust storms in general. And if you want to get there directly, that's mars.nasa.gov/weather.
And if I could just make one comment in conclusion. This is Jim at headquarters. Just how wonderful it's been to have this telecon and how remarkable the conversation has been. Keep in mind, we're talking about a rover that's been working at Mars, hanging in there for 15 years, when designed just for 90 days. It just doesn't get any better than that. Thank you for your time.
Thanks, Jim. That was a perfect wrap-up. All right. Thanks again, everybody, and have a great day.
Thank you for joining today's conference. That does conclude the call at this time. All participants may disconnect.